All right, so yeah, so what I think, since Buster and Callan aren't here today, we're going to go over the third test that's on the Math 125 website. So the spring 2019, and then that leaves the second one, first and second one, so you guys to go over on your own. We can go over those on Tuesday. You have a nice long weekend to go over all that stuff, but I figured it'd be good practice just to go through one from the beginning. And again, we'll just kind of go through how to solve the stuff and leave the details so you guys can finish on your own. So, all right. So, number one here. I can make this a little bit bigger, perhaps. So, what do we do, Juan?
We're going to have to do long division.
We're going to have to do long division.
Is it partial fractions?
And then probably partial fractions. So, let's practice the long division because that seems to be troublesome, right? So yeah, so it looks like a long division. We can't always look for that x squared plus 1 we can't factor, right? X squared minus 1 you can factor, then maybe some kind of weird factoring thing, but this one we can't factor. So long division, so we go x squared plus 1. How many times does that go into x squared minus 2x? 2x minus 3. Okay, so x squared and x squared is 1. 1 times that is x squared plus 1. Subtract. X squared minus x squared is 0. Minus 2x minus nothing is minus 2x. Minus 3 minus 1 is minus 4. Since that does not have an x squared in it, which it never will, you only ever do this once, right? Probably, well, I don't know. Actually, that's not true. If this was an x cubed or something. But if they're the same, x squared and x squared, you only do this once because the x squared goes away. If it was an x cubed in the top, you might have to do it twice. Okay, so then we're done. So this is what we integrate, and then this is a remainder. So this becomes the integral of 1 plus this over that. So negative 2x minus 4 over x squared minus 2x. Actually, I bet this factors, right?
Yeah.
So let's see, that would be x minus, because that's a minus 3 x plus 1. And on the top, let's factor that. So it's minus 2 times x plus 2. Well, that doesn't really help. Minus 2x minus 2x minus 4 minus 4. So dx, yeah. Okay, I was hoping that the x plus 2 might factor something on the bottom. Then we don't even have to do partial fractions if that was the case. But it doesn't. So now we got to do the partial fractions thing.
Should we leave it as 2x plus, or should we just switch it back to x? Negative 2x.
No, so what I would do, okay, this is easy integral, right? So now it's this integral. So I would just say take the minus 2 out in this integral of x plus 2 over x minus 3 x plus 1, right? So just take, it's always good to take something out, especially negative 2's, right?
Yeah.
Just take it out. Now we do the partial fractions thing. So this thing here is equal to a over x minus 3 plus b over x plus 1 multiply both sides, right? So you get x plus 2 multiply both sides by what's in the bottom. So the x minus 3, so it's a, it's always the one that doesn't have. The x minus 3 goes away, we multiply it by that, so it's x plus 1 plus b times x minus 3. And then we solve for, and now there's a couple ways we can do this, right? We can say let x equal negative 1, or else we just, there's lots of ways to do this. Shouldn't be too bad. Figure out a and b, and then we're going to have 2 logs. for our answer. So basically what we have, x is equal to ax plus bx, or divide everything by x. So a plus b equals 1. And then we have 2 equals a minus 3b. So a is equal to 2 plus 3b. A is 2 plus 3b. Plug that into here. Running out of room. 2 plus 3b plus b equals 1. So 4b is equal to negative 1. Or b is equal to negative 1/4. And therefore a must be 5/4. So a must be 5/4, since 5/4 minus 1/4 is 4/4. I think that's right. Is that what you got?
So I change the a for 2 plus 3b to this side.
Yeah, so 4b is equal to 1, negative 1.
So b equals negative 1/4.
Yep.
Negative 5/4.
And then a must be 5/4, because take away 1/4 and you get 1.
Alright.
And now it's easy, right? Now this is a natural log. This is a natural log. Don't forget the negative 2 out in front. And then we have the integral for the 1 in the beginning. Okay, so you can finish this on your own. I think we got the basic idea here, right? So long division, and then doing the A, B thing. All right, so that was the first one. Let's see if we can get through this whole test, just going over the basic idea. They do have solutions, so you can always check. All right, that's the first one. The next one looks complicated. Has to be a by parts. When you have an ln, you always let u equal the ln part, because it's easy to take the derivative of a log. It's hard to integrate a log, easy to take the derivative. Now the question is, do we let u equal the ln of y, or do we let u equal the ln of y squared? And I think we have to let u equal, you always let u equal a part of it, so it has to be the ln of y squared. Yeah, so when you're doing it by parts, you always have to let u equal the whole thing. It's not obvious that this is going to be easy, right? Let's just start it. So let's see what happens. It looks like it's going to be a mess, but what else can we do? So u equals ln of y squared. So du is 2 ln of y to the 1 times the derivative of ln of y, which is 1 over y. Again, this is dy. Not obvious this is going to get us somewhere. Then we let dv equal y squared dy, so v is equal to y cubed over 3. U dv, yep. Again, this is looking ugly, but the uv is always easy. So uv is this ln of y squared times y cubed over 3. And let's hope this integral works out. Minus v du. So y cubed over 3 times all that nonsense times 2 ln of y times 1 over y dy. Oh my gosh. Is this any better? Oh, wait. I get it. Okay, here's the cool thing. This, when we separate this, this is minus 2/3. 2/3. Y cubed cancels out the y. That's y squared. So y squared. Oh, wait. Y squared minus 2/3 y squared ln of y. Y squared ln of y dy. Okay, it's a little bit better, right? It's not ln of y squared. So now, I believe, all you got to do is integrate by parts again. Do the exact same thing. Let u equal ln of y. Then the ln is going to go away. So we have to integrate by parts twice. That's how you do this one. The first one gets rid of the ln of y squared. The second one will get rid of the ln of y, and then you're just going to have a y cubed. So then the tricky part here is keeping track of all the parts, right? Like making sure you remember this one and the minus 2/3 and all that kind of stuff. Yeah, so now you let...
Yeah, then it gets really simple.
Yeah, it gets really simple because this becomes a 1 over y. So you do it by parts again. U equal ln of y this time. Du is 1 over y dy. Same v. dv is exactly the same. So v is equal to y cubed over 3. And now it becomes really simple. Okay. So sometimes in by parts, you gotta do it. You gotta just go for it and do it twice. Again, the answers are online. You can check it out.
Then it's a third and y squared. Yeah.
Right. So that's easy.
Yeah.
Okay, let's move on. I know you can do that one. I want to move. Let's see if we can get through the whole test and not finish it. So yeah, but I would finish those on your own, leave some space, and then check your answers, because that's, of course, really important. But let's just kind of start them. Okay, how do we do this one? Number 2, e to the root t plus... One like this is going to be a u substitution.
With a square root of 2t.
Yeah, so the question is, what do we let u? And we want to have an e to the u. So I think you have to let u equal root 2t plus 1. And that's not obvious this is going to work. Looks ugly. But let's see what happens. So du is 1/2 2t plus 1 to the negative 1/2, which is 1 over 2. It's always 1 over 2 the square root of 2t plus 1, which is 1 over 2u. Right? Because u is root 2t plus 1, so it's 1 over 2u. du. Always forget. dt. dt, always for the dt. Wait. du, u equals, so yeah, dt. Okay, so dt is 2u du, right? dt, put the 2u over here. dt is 2u du. So this becomes integral. Now again, here we can change the limits. Then we never have to go back. Let's try that. Then we never have to go back to t's. We can stick with u's. So when t equals 0, this is e to the square root of 1, which is just e. So e. When t equals 4, oh, it's e cubed, right? 8 plus 1, square root of 9, so it's e cubed. So we go from e to e cubed. Now we never have to go back to t's. Okay, so what do we have? We have e to the u times 2u du. And we never have to go back to t's. how do we do that? Because yeah, the dt is 2u du. So this becomes a by parts. This has to be a by parts. Now, e to u is easy because it's integral and the derivative is itself.
Yeah.
But letting u equal 2u, because this gets really complicated, right? U equal 2u.
So if you just do W.
Yeah, or what you can do is change this to x.
Oh, okay. Going back to
Maybe let's do that. So let's change that to x. So let's say this is e to e cubed, e to the, because it gets really confusing, right?
Yeah.
Times 2x dx. Doesn't matter what the letters are, same thing. So, yeah, so what you do is you let u equal 2x, du equals 2. It's a real easy by parts.
And then dv equals e to the x.
Right, and v equals e dx. So uv is easy. Let's just do the integral part. Minus integral of v e dx du is just 2. Okay, so super easy, right? Super easy, and because, yeah. Yeah, so real easy integral. Okay, so the trick for this one is do the right u substitution, go for it, and it ends up being pretty easy by parts. Okay, good. All right, cruising through here. Let's just talk about this one and not do it. So a sine cubed and a cosine squared.
Don't pull out sine squared from the sine cubed, right?
Right. So so if we do this one, 0 to pi, we take out a sine squared, we leave a sine, then we can do a u substitution. And the sine squared is 1 minus cosine squared times cosine squared theta, d theta. Now, we let u equal cosine theta. U equal cosine theta, du is sine theta d theta, which gets rid of this and that. So this just becomes integral from 0 to pi sine theta d theta is du. So 1 minus u squared times u squared du. And we got to worry about the limits. We can either get rid of them, but real easy. So whenever you have an odd number of one of them, it's a lot easier. If this was an even number, we'd have to do what we did yesterday with the half angle formulas and do all that nonsense. This is actually much easier. Whenever you have one that's odd, much easier. Okay, piece of cake. Easy, final. All right, let's do the next one. Hey, we have a real problem. Consider the area bounded by these curves. Set up to not, a volume one, good. We haven't done a volume one for a while. Okay, so they did a graph for us, which is nice. Rotating this area about the y-axis. So it's going to look like this. About the y-axis. It goes a little bit further. Whatever. Get the idea. So it looks like this. And they say don't evaluate, so either it's a hard integral or it's so easy that we don't want to waste our time. Okay, now notice if we do something like this, it messes up because it goes up and down, right? So what we want to do is the shelves. We want to go like this. Because then it's always from the curve to the bottom. If we do it crosswise, we draw our thing crosswise, it's going to hit here, but what about here? It just doesn't work, right? We'd have to break it up into two integrals or something. So we want to do a shells. We sweep it around like that. Remember how to do that one?
Is it
You
2 pi?
Right. So the easy way is you draw your shell. What does that? This thing swept around. That's cylinder. Right? So that's the cylinder. So the radius is x. The radius is x. So the circumference is 2 pi x. Again, if you draw the shell and you just think about what that looks like, imagine, you know, the cylindrical shell.
Yeah.
It's a good name for it. Then the height is the function, is y, which is x cubed minus 2x plus 2. Right? That's the height. X cubed minus 2x plus 2. And the thickness is dx. And now we're done. All right, so now we integrate from what? Y goes from, x goes from 0 to 1. So the integral of 0 to 1, 2 pi, I just multiply all those things together. 2 pi x, x cubed minus 2x plus 2 dx. I think they said don't evaluate just because it would take a long time and it's easy. Like, what's the point? We know you can do that. Because you would take like 5 minutes and probably make an algebra mistake, right?
Yeah.
So it's nice that they say that. Like, okay, the hard part is setting it up. That's a bad too. So, okay. Now, what's the next one? Again, so equal to split off by rotating this area around the horizontal line, y equal 2. So same thing. So we got to decide which way to do it. Around y equal 2. So let's see, what's y equal 2? Y equal 2. Y equal 2 is right here. So around y equal 2. Yep, that's what y. So we're going to rotate it about like that. So it's going to look like, ooh, that's going to be hard to draw. It's going to look like this.
Can we do the whole thing and then subtract on the inside?
You can.
The washers? Or
Yeah, because if we do it cylindrical shells now, we have that weird thing, right? So we got to do it up and down.
Yeah.
So let's see what that looks like. So we just draw a sample thing here. We draw sample 1. Oh, we don't need to. Oh, yeah. So we need to go. Okay, so here it's a shell. So how does that work? So it's integral. Okay, first off, it's a dx.
Has to be r.
Oh.
A big R minus little r.
Yeah, what was our formula? Y is equal to, what's this one again?
X cubed minus 2x plus 2.
Okay, there's no way we can solve for x. Can we? No. We're not going to get x as a function of y. Right? How would we do that? If we integrate with x,
Also, just do it in two separate.
yeah, because if we do it this way, it's a dx, right?
Yeah, we can integrate in terms of y.
But yeah, we have to have a dy.
Yeah, and then we can just do 2. Well, if it's gonna be the
Yeah.
exact same thing, we can just do half and multiply times 2.
Okay, let's see what. So we have to do it this way. Because if we get a dy, sweep it around. But what do we do when we get to right here, somewhere where it's. Huh. What happens when it gets to like right here? Like it goes. We have this little part here. So do we have to do that separately?
Well, if it's standing up, can we still do it? Because we did it standing up on the top one.
Yeah, but before it was always from this side to that side. But here it's like right here, it's kind of jumps. So I think we have to break it up into two integrals where x goes from here to here and then from here to here. It's like two different problems. So we need to figure out, wow, this is kind of hard. We need to figure out where that point is. Because it's like double.
Can we do dx though?
But if we do,
Pretty sure we could do dx.
maybe we do yeah. Maybe, what was I thinking? I was thinking we couldn't because we have to solve for x.
No, it's not. I thought we did dx and we never solved for x.
Oh, you're right. No, we do yeah. What was I thinking? Okay, ignore what I said there before. I don't know what I'm thinking. I haven't done this in a while either. Okay, let's go back to our original way, see if it works. Dx. So, we go around like this. And we got to subtract out the middle. So, it's always pi radius squared dx, right? Pi r squared dx. Cylinder. So what is the radius? So it's pi times the full minus this. Right? It's the full thing, which is 2. 2 squared. Pi r squared. So it's the full one subtracting out that. And that is 2 minus y.
Yeah.
2, that's 2 minus y. 2 minus y. So it's subtract out 2. Yeah.
Yeah, 2 minus y.
So minus 2 minus y squared. Oh man, what was I thinking about not solving for x or something? God, that was. Oh, yeah.
Yeah,
sorry, Calvin.
I agreed with you. I
Buster.
thought about it.
I know, I convinced you too. Like, you should have. Okay, now it's easy. We plug in y, we plug that in, right? So it's integral of pi 4 minus 2 minus all this. Oh, the 2 minus that, the 2 is going to go away, right?
Yes.
2. So really, it's going to be 2x. Really clever. Minus x cubed squared dx. Because 2 minus this becomes minus x cubed plus 2x minus 2. The 2's go away. Okay, whatever. That's just all. Okay, so that's it. We don't have to evaluate it, thank goodness, because that'd be a lot of work and it's easy. Oh, and at any rate, x goes from 0 to 1. That's important. All right, so that is the not cylindrical shells, but the washers. Washer. Right, hole in the middle. The whole thing minus the hole in the middle. All right, that's a good review. For me too. All right, let's see if we can do some more here. What's next? Oops. What is next? Okay, this is the total distance one. Let's just set this up.
There's 9 pages of that.
So we have a particle moving. Yeah, they give you a whole page. It's going to be long. Particle moving. Find the total distance traveled. Here's acceleration. So again, the distance is the integral of the velocity. We got to find the velocity. The velocity is the integral of the acceleration, which is the integral of 1 over 2 root t. They tell you v is 0 is negative 2. So you do this. When set time equals 0, negative 2 to get the c. When you get your plus c. Go from 0 to 9. And you got to figure out when it's 0, just like we did yesterday. So I think you guys see, this is going to be a little bit tricky. It's a weird acceleration, right? But I think you can do it. Just like we did yesterday. you got to figure out when in this interval is it positive, when is it negative, and you have two integrals, right? So you can have two integrals for this.
And then whatever is negative, just make it positive.
Whatever is negative, one of them is going to be negative, make it positive, add them together.
Okay.
Yeah. Okay.
I got this one.
Yep, that's good. Okay. Oh, the 0 to infinity ones. That's a good one to do. So, oh my gosh, look at that. X cubed plus 2x plus 2 to the 3 halves. So we got this, first we got to integrate it and then plug in 0 and infinity. Okay, first off, will this be 0 at any place in between? And I think we need to write this, complete the square or something, because it looks like it's going to be and it'll be easier to see if we complete the square.
It's going to do the cube root of it squared.
Yeah, so it looks like
Square root of it cubed.
It looks like it's going to end up being a trig sub, and we're going to have to do some fancy games here with writing this as a complete the square. So let's do that. So this thing is x squared plus 2x plus 2 is x plus half of that, x plus 1 squared. So it's half of that, because that gives us the 2x. X squared plus 1x plus gives us 2x. That gives us 1 too many. So minus 1 plus 2. So obviously it's plus 1. So it's x plus 1 squared plus 1 to the 3 halves. This will never be 0. From 0 to infinity, because this is always positive and this is always positive. So there's not something in between where this is going to be 0. We're never dividing by 0. So that's good. So we just integrate this from 0 to infinity. So that is the integral now from 0 to infinity. Oh, and this is, of 1 over that. So we had to complete the square to do it in the way that we, so it would be of x plus 1 squared plus 1 to the 3 halves. So what I do is get rid of that x plus 1, let u equal x plus 1, du equals dx. So it becomes, oh, and let's change the limits. When x equals 0, u equal 1, and then x equals infinity still, of 1 over u squared plus 1 to the 3 halves dx. And we don't have to go back to x's because I changed the limits, right, to 1. Okay, that's a trig sub. Which one is it? It looks like a squared plus x squared, so x equals a tangent theta. A is 1. So it's u squared plus a squared, a is 1. So we let u equal tangent theta. du is secant squared theta d theta. Oh, this is a u, not an x. So tangent squared plus 1 is secant squared. So this becomes integral from 1 over infinity of du. So it's 1 over secant squared theta to the 3 halves is 1 tangent squared plus 1 is secant squared times, don't forget the du, times secant squared theta d theta. Okay, this is tricky. This is 3 halves, this is squared. secant squared theta
Secant to the third.
to the 1/2 square root of secant squared is secant. Yeah, so secant to the third. So it's secant squared over secant third.
So 1 over secant.
So it's 1 over secant, which is 1 over secant is just cosine.
So that's easy.
Yeah. So this is just the integral of cosine d theta from 1 to infinity. Whoa. That does not converge, right? Because cosine goes back and forth.
Yeah.
It's not. You're not going to get an answer.
So it's divergent.
Or this is the integral of cosine is sine theta. So it's sine theta from 1 to infinity. Except we got to go back to this is now we got to be careful because theta doesn't go from 1 to infinity.
Oh,
We got to be careful with this. U goes from 1 to infinity.
We gotta go back to
We got to go back to U. So maybe that was wrong. So we have time. Let's quickly do it. So we got to do our triangle here. So we got to go back to U. So theta, and we said that U equal tangent theta. So tangent theta is U over 1. Opposite is U. Adjacent's 1. This is the square root of U squared plus 1. Sine theta is opposite over hypotenuse. So really, it's U divided by square root of U squared plus 1, opposite over hypotenuse from 1 to infinity. Okay, now we can do it. Okay, so boy, that earlier stuff was wrong because we have to go back to U's. Now, what happens when U equal 1? Or we equal infinity?
Well, when you put 1,
Okay, the 1's easy. You put 1 in, you get 1 over square root of 2. When you put infinity in, we get infinity over infinity. But this is the square root of this. Okay, so the way you do these, you go, oh wow, this is hard. The way you do these, you have to remember how to do limits. What you do is you divide the top and the bottom by U. If you divide the top by U, U divided by U is 1. Divide the bottom by U, you put the U inside, so it's U squared. So it's the square root of U squared over U squared plus 1 over U squared. That's 1. When U goes infinity, that's 0, so it's 1 over 1, which equals 1. So when you plug in infinity, it's 1. So it's the answer is 1 minus what you get when you plug in 1.
It's 1 over square root 2.
1 over root 2. Whatever that is, and that's a number bigger than 1. So it does converge. Okay, so actually it does converge.
U squared.
So the answer is 1 minus 1 over root 2. That's the perfect answer. So it converges. Craziness. So yeah, so you got to be careful. I looked at that, but that's not theta. Theta doesn't go from 1 to infinity.
So
U goes from 1 to infinity.
So when
All right.
you do, yeah,
I'm going to stop there. So
yeah, I get it.
did you get this part, the limit part?
Yeah, you have to divide both sides, or top and bottom,
Right.
so you get a 1 at the top.
Right? And then you put a U square inside the square root. This is 0, because then U goes infinity. 1 over infinity is 0. It's 1, so it's just 1.
Yeah.
That was the old limit tricks. Okay, good. Hope you guys listen there. Bye.